Okay, Reed. Reed, can you sub some numbers in for me, please? Go ahead. What do I do?
Well, for the first half of x plus h, you know, 3 x plus h plus 2. And then we do the same thing.
The minus
X's.
Now, please remember what I did here is, if I can form that out, is you subtract the entire thing, right? So the entire thing's in brackets, so it'll switch the signs. Okay, Dakota, how's your foiling skills? 3x plus h squared turns into what?
Okay, it turns into 3x squared
Yeah.
plus 6xh.
Yeah.
Plus 3h squared.
Yeah. Keep going.
I kind of mix this up.
It's okay, just go from there. Go ahead.
Plus 1
Okay.
minus 3x squared minus 2x minus 4.
I don't know if you said this, but I'm putting it in here.
Oh yes, I forgot that term.
Minus 3x squared minus 2x minus 1.
Kept it in your brain. Yes.
Okay, things are looking tremendous, wonderful, even. Sam, what do I do now? Okay. Now remember the beauty of calculus, things will always cancel out wonderfully. Okay? And hopefully when you're doing your limits last night, you saw that too. Okay, you may have, Sam was telling me she had to erase and start over for a few of them, and that's okay. If you remember identities in grade 11 and grade 12, Matt? If you remember identities in grade 11 and grade 12, it's okay to have to restart. It's not going anyplace, and that works. So this turns into 3h squared plus 6xh plus 2h, is that right? Over h. Okay, Matt, why am I happy? Cancel the h's. So this turns to be limits of h approaches 0 of 3h plus 6x plus 2. Okay. So what is the limit of this, Robert, as h approaches 0? What's equal then?
6x plus 3 times 0 plus 2.
Good.
So that's 6x plus 2.
Yeah, that's cool. That's what we're doing tomorrow. Okay, that's what we did.
Now what do we do with that?
Do you want
That's
to
right.
solve?
Well, what I would do, we will do that eventually. Okay. Because that's going to be your slope of that at any point is 6x plus 2. Okay, so we can use that for a lot of neat things like vertexes. As I don't want to get too ahead of ourselves here, but what would the slope be at a vertex? You're thinking for this, we're like, here's my beautiful
0.
0. Good, right? So in order to get what a vertex is, you just solve that equals 0, and that's your vertex, which is awesome. That's going to be accurate. Good. Let's do a little homework takeout. I'll start with 1D, 3A, 3D, 4C. Okay. You're using incredible amounts of paper. Remember how I said the first day not to have a binder this big because it's not going to work? And you guys go, yeah, whatever, Mr. Sadler. I can use the smallest binder in
Put all
town.
my warm-up questions on one sheet of paper, but I have two sheet of paper.
Oh, this question 1D. Okay. There are two ways to do this one, and both of them will work. Let's start off with the easiest way. Okay, and this is me being mean, okay? The easiest way is to factor. Rationalizing will work as well. I will do rationalizing, I will also factor. What's common between all of those things? Nope. Root x. Okay. So you can write it like this by factoring. What does the numerator change to when you factor out a root x? Or root x minus 1. We can rationalize in a second, which I'm going to do. Okay, John, why am I happy? Because I'm always happy. But why am I happy? Actually, why am I happy?
Well, why do you factor in 4 root x minus 1?
Okay, because what happened was root x times 4 root x is 4x, right? And root x times negative 1 is root x. The reason I did this is because remember for limits, you weren't here yesterday, but remember for limits, you want to avoid the 0 over 0. right? That's the problem with all these. So what's causing the 0 in the denominator is root x, right? So you're just gonna take that out. Okay, there's millions of different ways to get this one. You're probably looking at your paper and say, I did it a different way at home, but yet I hope we will get negative 1/3, right? Which you will get. Right? The root of 0 is 0, right? Because 0 comes first. Yeah. Yes, you certainly can. That's what I was hoping someone would say. Just cancels. You're left with limit x approaches 0. 4 root x minus 1 all over 3. Which turns into, now I'm going to sub in x equals 0, and you get negative 1. There are other ways to get that. Okay, so I'm going to show you more ways to get that. I can show you more ways to get that if you want to. Somebody will, I do the rationalizing way. You want me to do the rationalizing way? Okay. Some people times by root of x, or 3 root x, or whatever, they get the same answer. I'm going to do the rationalizing. Now, if you want to rationalize this, what should I rationalize, the numerator or the denominator, and why? Yes?
Denominator.
Can you rationalize the denominator? That will work. It'll work.
Yeah.
I would choose the numerator though. The denominator will work.
Okay.
The numerator I normally use because it's plus or minus the square root, right? Because as soon as you see minus the square root, you can change it then to plus square root, right? So that's, it will get really ugly, unfortunately. There's a million different ways you can get this. I'm going to do it my ugly way, then I'll choose Reed's way next, okay? My ugly way, oh, math is beautiful. Option number 2 turns into limit x approaches 0, 4x minus root x all over 3 root x times 4x minus or plus root x all over 4x plus root x. Okay, this turns into, I want to go through this quickly, guys, because we got lost in it. This is 16x squared plus 4x root x minus 4x root x minus x all over 3 root x times 4x plus root x, which turns into 16x squared minus x all over 3 root x 4x plus root x. All right, if you get to the stage, you're probably saying, yuck, that looks like a lot of messiness, which it is. Can I get somebody to give me the brilliant solution at this point? What has to cancel? X has to cancel, right? Okay, so the numerator I'm going to pull out an x. And I call that 16x minus 1. Okay. What's that? One more time, this one?
Get rid of the square root.
How would I do that? Distributes, perfect, that's the word I was looking for. So 16x root x plus 3x. Okay, so now if you take a look, there's an x in the denominator as well too. So this turns into limit x approaches 0, 16x minus 1 all over 12 root x plus 3, which is also then equal to negative 1/3. Is this awful? Yes. Is that way nicer? Yes. Okay, right? Yeah, Matt?
Yeah, just for the denominator, took out the x.
Yeah.
How come the x wouldn't come out of the root x as well?
Because this is like, the way you're thinking of this, 12x root x is like 12x to the 3 over 2, right? So there's one full x and then another half x in there. So if you take out, if you're dividing by x, right, if you divide this by x, that's just, whoops, that's 12x to 1/2, or just, you know what I mean, or square root of x is all that's left. Right, because when you divide, you don't even factor out an x, that's just an x to the 1 that you're getting rid of. So just think of like power rules, right, in fact,
Okay, but like, let's say you get 12x plus root x, then you have to do it.
yeah, if you had 12x, if you had 12x plus root x, right, and this is sort of what I did over there, factoring out the root x. If I had 12x plus root x, you can do this. Okay, because that's, you know what I mean, that'll work too. The reason I had to get an x, because I took an x out here, right, that's what I was looking to do. Okay. Do you want me to show you option 3, or are you sick of this question by now? Want to see option 3? You really don't want me to teach it all day, that's fine. Option 3. Option 3 is limit x approaches 0. 4x minus root x all over 3 root x times 3 root x over 3 root x. The point I'm trying to say is here, there's a million different ways to get to the final answer on this question, okay? So if you said I didn't do it that way, that's fine, okay, as long as you get the right answer. This turns into limit x approaches 0, 12x root x minus 3x all over 9x. Okay, why am I happy? X is everywhere, okay? In fact, in the numerator, there's a common factor of 3x, and you get 4 root x minus 1 all over 9x, which turns into lim x approaches 0, 4 root x minus 1 all over 3x, stroke 3, which turns into negative 1/3. So there were 3 ways to get that, right? So if you didn't whether either way of rationalizing or taking out a common factor, there are 3 different ways to get that. Whatever way is nicer for you, do. Right? They're all correct. Right? We got negative 1/3 no matter which way we did it. Okay? I know you guys as mathematicians like, to have the same, the same style of question, right? But everything's going to be a little bit different. This makes me happy as a math student because there's not just only one way to get it. Right? You can sort of play around with these a little bit so you get it to work. Right? Some people don't like that. I'm going to hit pause and stop, and then we're going to go on to the next question. And I want everyone to put their heads on the desk.